Okay, here we go. Last example. Once again, I'm going to have you start by doing the first 3 rows on your own using what we've learned from the past 2 videos and from past math classes. So pause the video right now, try to fill in the first 3 rows, and then graph those points. Welcome back. Check what you got with what I got. Wholes don't have any, nothing cancels. Y-intercept set x equal to 0 and solve, should get that. Set the denominator equal to 0 and solve, we would root by a negative number, so there's none, which means our domain is all reals. And then x-intercept set the numerator equal to 0, get that. Our end behavior is a little interesting. We get x over square root of x squared. So if x is a positive number, say 10,000, I get 10,000 over 10,000 squared square root. So that's going to be a positive 1. However, if x is a negative number, say negative 10,000 over square root of negative 10,000 squared, that's going to be a negative 1. So it goes in different directions depending on if it's positive or negative. Okay, so that's what we've got so far. Next, pause the video and try to find your critical numbers for each equation, and then come back and see how you did. Critical numbers for this one are a little interesting. For our original, numerator is 0. Denominator we already know doesn't work because we squared a negative number. For the first derivative, you set the numerator equal to 0, but that doesn't make any sense, so none. And we know the denominator doesn't work, so the first derivative doesn't have any critical numbers, which basically means the first derivative is all positive or all negative. You plug in and see. Second derivative, numerator is 0, denominator doesn't work. So when we come here, we really actually only have the 2 critical numbers, one on the original, one on the second derivative. Now pause the video, plug some numbers in, and fill in your number lines to see what you get, and then we'll come back and talk about what all of that means and graph it. This is what you should have gotten for your number lines. So let's look at the first one first. Remember, on the original number line, negative means below the x-axis, positive means above the x-axis. So I'm going to box those in to remind me where my graph should go. It looks like for f prime, this entire graph is always increasing. So the whole thing should be increasing the whole time. And for here, remember this is concavity, and it looks like with this concavity, I have a point of inflection at 0. This is where it's changing from concave up to concave down. No maximums or minimums because your first derivative never changes. But we do have a point of inflection here at 0, plug it in to get 0. And we know, so now we can start to graph. Left of 0, this has got to be increasing and concave up. So something like that, that's increasing and concave up. And the right half needs to be concave down, but still increasing. So increasing, but concave down. There's our frowny face, you can kind of see. But it's still increasing, it's still going up. And that's how this final graph should look. That's it for 5.1. You should be able to get started on your assignment now.